Alright, welcome to Chapter 4, the structure of the atom. In my opinion, this is where chemistry really gets going here, because we're going to look at what atoms are, and this is really the basics of chemistry, so let's make sure we get this down. Our first video will be 4.1 on early ideas about matter, and here we're going to compare and contrast the atomic models of Democritus, Aristotle, Dalton, Thomson, and Rutherford, and to understand how Dalton's atomic theory explains the law of conservation of mass. Alright, so early ideas about the atom really began with the Greek philosophers and what they thought of matter. They thought matter was made of 4 elements: earth, air, water, and fire. And that those 4 elements could be combined in different amounts, and you could produce different things, like air and fire would make hot, and earth and water would make cold, and those are like opposites. Wet and dry could also be produced, and essentially everything on this table here is opposite from the other side there. This is what they believed in terms of the first 4 elements. They also believed that matter could be endlessly divided, which would be like taking a sheet of paper and then going cut, 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 and you just basically keep cutting in half until it's all gone. But they basically said you could do it forever, and that was kind of the early ideas about the atom. One of the first philosophers, though, to kind of think something different was Democritus. Maybe you've heard of this guy, I don't know. But basically, he believed that matter was made up of tiny particles called atoms, which means indivisible, like you can no longer divide anymore, or basically the word atom is what that means. And he believed that atoms were solid little particles that move through empty space. He also believed that matter could not be created, destroyed, or further divided. A more well-known philosopher, and you've probably heard of this one, his name was Aristotle. Aristotle believed that empty space could not exist, so he disagreed with Democritus on that issue. He believed in the 4 elements, and basically because he was a more well-known philosopher, Democritus' ideas were ignored, and they were ignored for almost 2,000 years, and the idea that matter was endlessly divided kind of continued, and Democritus' idea of atoms was forgotten. In the meantime, before science really got its hold on what matter is and chemistry became what it is, there was a pseudoscience called alchemy that dominated the Middle Ages. And basically what alchemy is a pseudoscience, or a false science. Remember, to be a true science, you have to have a hypothesis, you test it, and you can support that idea or disprove it and change it. Pseudosciences like alchemy was really more just kind of the guessing, kind of praying that things would work out. Alchemy really focused on turning metals into gold and silver metal, which are more desired, I guess. They worked on making chemicals like the elixir of life, which is supposed to prolong life or make you feel more youthful. And essentially, alchemy was a pseudoscience because it was more just let's mix and see what happens kind of thing. Now, not all alchemy was that way. Eventually, it became more scientific, that there were more note-taking. Go away. There was trying to reproduce results and that kind of thing. So it became more scientific over time, and it did lead the way for what chemistry really became, which is a true science. So although alchemy was a false science in its early origins, it did eventually become more scientific and then led the way to chemistry as we know it today. Atomic theory was created by Dalton, and what Dalton really did to create his atomic theory, these things you're going to write down here in a second, he basically took the ideas of different people, A, B, C, and D, those guys out there, whoever they might be, and basically took all their ideas and he compiled them together into his own theory. Now, Dalton did a lot of experimenting himself, but he took their ideas and combined them into one large theory called atomic theory. And let's write these down here one at a time. The first one is that matter is composed of extremely small particles called atoms, which we get from Atomus, or from Democritus. So that atoms are indivisible and indestructible, which means eventually you can't divide them anymore. 3, so that atoms of a given element are identical in size, mass, and chemical properties. 4, atoms of a specific element are different from those of another element. 5, atoms combine in whole number ratios to form compounds. And what that really means is, when you think of a chemical formula, it's always whole numbers, H2O, that's 2 hydrogens, 1 oxygen, or methane, which is CH4. You never see things like HO and a half, which would be a way to simplify H2O. we always do whole numbers, and that's what happens. Atoms combine in whole numbers to form compounds. And then number 6, in chemical reactions, atoms separate, combine, or rearrange. And this right here, why don't you take this and call this the law of conservation of mass. That's what he's basically trying to state there. Alright, so this is Dalton's atomic theory. A bunch of good ideas that are well tested, well supported, and explains for what atoms are. Before we move on, let's look at number 2 and 3 here. We're going to put light x's over on indivisible and indestructible, and over mass. Basically, as science developed and grew, more technology allowed us to find out that atoms could be divided, which are protons, neutrons, and electrons, we'll talk about in the next video. And we can destroy matter, which we'll talk about later in the year. And then also that atoms of a given element, they are identical in size and properties. However, they can have different masses. So all atoms of carbon don't all have the same mass. And we'll talk about that in video 3 when we talk about isotopes. Kind of wrapping things up here. So after years of studying chemical reactions, Dalton was able to accurately determine the ratios of elements involved in reactions. His conclusions resulted in his atomic theory, which basically explains that atoms are separated, combined, or rearranged in chemical reactions. Atoms are not created, destroyed, or divided. And the point of the picture here is to show us that basically before a reaction happens, what you start with is what you end with. Nothing more, nothing less. Okay? So basically we have 4 orange atoms, and we have 8 blue or purple atoms. And when they combine to make, looks like water here, I guess, H2O, basically you still have 4 O's and 8 blues. So they just combine, separate, and rearrange to form something new. And that's kind of how Dalton explained the law of conservation of mass. Alright, in the next video we'll be looking at how to define what the atom is and some of the experiments that led up to finding protons, neutrons, and electrons.